All right, folks. Let's go ahead and solve all of these questions. You'll notice that I'm going to work vertically as we go through this. So I'll just use blue for the first one. So remember, my goal is to end up with like x equals something, right? In this case. That's my goal. That's where I'm trying to get, okay? So I want to undo the operations that are around x so that I end up with x. So I've got multiplication here, and I've got addition here. So I'm going to subtract first. So I'll subtract 40 from both sides, right? So I minus 40 from both sides, and I have 6x is equal to, and if I subtract 40 from that, I can use mental math, or I could use a calculator. It's always best to do it with mental math if it's a number that you're comfortable with. Okay, so now I have 6 times x. I need to undo the multiplication so that I end up with x, right? So I'm going to divide both sides by 6. So if I divide by 6 to both sides, now I'm going to get x, right, is equal to 12. Okay, how do I know that's correct? Well, I can go ahead and substitute. So if I substitute 12 back in here, 6 times 12, that's 72, plus 40 is 112, so that works. I'm just going to erase this here. Don't need that there, but that's always our goal. We're going towards isolating x. That's also called isolating, right? I want to get x by itself. Okay, so now I've got multiplication and I've got subtraction. And if I can add to undo this subtraction, I'll have 7x, which is getting more isolated. Is where I want to go. So if I add 15 to both sides, oops, that will undo the subtraction, or that could become 0, I guess. So 7x is equal to, if I add 15 here, I'll have 42. Okay, so now I want to undo the multiplication, right? Well, I just divide. So if I divide both sides by 7, I'll have x is equal to 6. Again, I can go and check back by substituting 6. 7 times 6 is 42. 42 minus 15 is 27, okay? So put a box around that answer. You don't necessarily have to show the division and the addition. I'll show you what I mean by that. So when I go here, this time I think I want to isolate x on the right, which is fine, okay? So what I'm gonna do is, I think I'm going to subtract 8 from both sides here, because then I'll get x there. So when I do that, I'll have 12x is equal to negative 48. Notice that I didn't show the minus 8, but I still went vertically. I still have my equal sign. And then looking back on the other questions, you can see my equal signs, they go down in a vertical manner. I'm not working sideways. I'm always working vertically. Okay. All right, so I want to undo this multiplication, so I'm going to divide both sides by 12, and that will leave me with x here is equal to negative 4. And then I can rewrite that if I really want to as x equals negative 4. This is called the reflective property of equality. Basically, it means that if negative 4 is equal to x, x is also equal to negative 4. Okay, it's pretty obvious one. I would accept either. You could have the first one here or the second one. It looks a little nicer when we write it in order that we would want to read it, to say that x is negative 4. Okay, let's look at one more, and then I'll make another video for the other ones below. Okay, so let's see. I've got division. And, as long as I do the same to both sides, I could undo the division on both sides first. I think it's probably more appropriate to undo the subtraction first. So if I add 3 to both sides, That will leave me with x over 6. And if I add 3 to this side here, that would be negative 8, right? Now, to undo that division, okay? So how do I undo division? I multiply both sides by, well, dividing by 6, the inverse of that would be multiplying by 6. And I must do the same to the other side. I must multiply on the other side too. So that undoes the division. 6 divided by 6 is 1. That's just x equals negative 48. Okay, let's just double check that. So if I go to substitute here, negative 48 divided by 6 is negative 8. Negative 8 minus 3 is negative 11, so that does work.